Okay, we're going to talk about the cosine rule again. I'm going to have an example of the cosine rule. You'll remember that my standard example for Pythagoras is the 3, 4, 5 triangle. What I'm going to do is apply it to a 3, 4, let's say 4.6. And there's 3 and there's 4. And I'm going to work out what that angle is there. So I'm going to label my triangle here, which is let's say BC. That's side A, that's side B, and that's side C. And what we want is we seek angle A. We seek that because I want to know what this is. We know it's a right angle if it's exactly a 3, 4, 5 triangle. And of course it's 3, 4 but 4.6. So it's like this line here, it's like a spring and it's going boing, 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 and it's moved this way and contracted that angle. So we know that A is going to be less than 90 degrees. And if it's not, we've got a problem. Okay, so how do we do that? How do we figure out what that angle is there? Well, we write out the cosine rule. A squared equals B squared plus C squared minus 2BC times cos A. And then we bring this minus 2BC cos A over to that side of the equation. And I bring that over there as well. So I say that 2BC times cos A equals B squared plus C squared. Those two terms were being there already. Minus A squared, which is there, so it turns into a minus. And of course the negative sign turns into a plus sign here. And then I'm going to take this 2BC over the other side. So cos A equals B squared plus C squared minus A squared over 2BC. And we know what those angles are because there they are. So A and B were 3 and 4. No, they weren't. B and C were 3 and 4. So that's equal to B squared was 9 because 3 3s are 9, plus 16 because 4 4s are 16, minus 4.6 squared over 2 times what? Times B times C, which was 3 times 4. 3 times 4. So the bottom is 24, isn't it? Because 2 3s are 6 times 4 is 24. And here we've got 9 plus 6 is 25 minus 4.6 squared. I may as well do it longhand. 4.6 times 4.6. 6 6s are 36. Oops. 36. 4 6s are 24, 25, 26, 27. 4 6s are 24. 16, 17, 18. 6, 1 down, 1 to carry. 1 down, 1 to carry. 21.16. So that equals 25 minus the 4.6 squared, which I've just worked out here, 21.16, divided by 24, equals what? Well, it's 25.00, take away 21.16 to work out the thing on the top. That gets to 10, that goes to 9, that's 4, 4, 8, 3, and there's a 0, so it's 3.84. Equals 3.84 divided by 24. So, just refreshing our memories. Oops. Cos A equals B squared plus C squared minus A squared over 2BC, which equals this, because that is B squared plus C squared. That is B squared plus C squared minus A squared, which is 4.6 squared, over 2 times B times C, which is that, which is this, which is 3.84 over 24, which I cannot be bothered to work out, so I'm going to go whoop, 3.84 divided by, what was it, 24. 24 equals 0.16, I think. Yes, 0.16. So what that tells us here is that cos A equals 0.16. So what's A? Well, A equals arc cos of 0.16, which is a bit difficult to work out by hand. So I'll just work it out by the calculator. Arc cos, you see it says cos minus 1 there? That's the one we want. Boink. 80.79 degrees. 80.79, I think it was. 80.793 and then all these other digits, degrees. Okay, so that's actually quite close to a right angle. Remember I said we knew that the right angle triangle here, the 3, 4, 5 triangle, that's an exact right angle. Well, instead of a 3, 4, 5, we've got a 3, 4, 4.6. So it's actually contracted this angle down from a perfect right angle down 90 degrees going down to 80 degrees. Well, that's quite nice. That's quite nice. And we could use the cosine rule to work out these other two rules here simply by rotating our triangle around and relabeling them. So I think that's quite nice. I'm going to stop there.